Dr. Tanuj Mishra has been our student also at the Indian Agriculture Statistics Research Institute. He did his PhD in machine learning techniques, where he specialized in image processing, which he is going to take topic of today also. And he has knowledge of statistical methods, survey sampling, statistical design, but major specialization in image processing softwares as well as algorithms, deep learning, that too, and having knowledge of Java, Python, C, and many other things. But as I introduced you all in one of my lecture about AI, machine learning and deep learning, some difference I tried to give you. After listening to his lecture, you will be able to clearly grasp what exactly is AI about and what are its potential. He is going to do that with real application on which he worked. So he, as such, did his BSc in agriculture from Uttar Banga Krishi Vishwavidyalaya, West Bengal, and MSc from ISRI, PhD also from ISRI. So he has, out of his PhD, he has published very good work, like some papers in more than 8, some in 10 NAS rating journals. So he has also participated in international conferences to present his work and delivered many lectures on this. So his software which he developed for finding out leaf area and chlorophyll content in the leaf based on image, so that are available in the public domain. One of his software on spike detection and counting from wheat, a visual image, wheat's visual image, that also is available in public domain. So another software is available in Nanaji Deshmukh Plant Phenomics Center at IRI. So he has very good knowledge of this AI. So I thought it is good to introduce to our participants for this emerging technique. So with these words, I would like to welcome you, Tanuj, for this lecture today morning to the participants. So thank you very much for accepting our.
Thank you.
I know
thank you, madam. And I have completed my MSc and PhD, and in both degree, you are one of my advisory committee members, and you had a significant contribution. And maximum time, जब भी कोई issues आता था, आप solve करते थे. And thanks for giving me the opportunity, ma'am. And
thank you. So carry on with your presentation. We have in this training nearly 115 participants, but today morning, right now, 79 are there. Maybe more will be joining soon, but you can begin your presentation.
Okay, thank you, ma'am.
Thank you.
And then thanks to the whole organizing committee members of the 21 days winter school. The topic of analytical techniques for decision making in agriculture, very important topics. So, madam, I'm going to slide share.
Share the slides. Yeah, it is shared.
Okay. Is it visible? No?
Yes, it is visible.
Okay. Is it moving? Okay.
Yes, moving.
Okay, okay. So thank you, ma'am. So today's topic is the application of deep learning in agriculture. And deep learning is actually the need of ours. And in particularly in the agriculture sectors, where mostly deals with the unstructured data today. So what is unstructured data? Unstructured data is like image, the text, the voice, and day by days, actually, the remote sensing technologies, drone technologies, and imaging technologies is gaining momentum. So deals with these types of data, the huge data, so-called the big data, and from this big data, we have to extract the pattern, we have to extract the features, and from which we have to develop the statistical model for prediction or estimation. So for this purpose, deep learning is a very important topic. And before directly going to the deep learning, we need to know the what is artificial intelligence, what is machine learning, and then deep learning. Actually, artificial intelligence is a very big umbrella term under which machine learning lies and under which deep learning. And the network structure of this deep learning technology is inspired by the human brain structure, which I will cover in the later slides. And the basic structure of the deep learning is the artificial neural networks. So in this lecture, I will also cover 1 to 2 slides for artificial neural network. Then the application of deep learning in the real world scenarios and in the agriculture. And then we'll learn the inner technologies of the deep learning techniques. So what are the inner technologies? Actually, lots of seminars or conferences of deep learning techniques in agriculture or in the real world scenarios, I think happen. But the inner technology, how deep learning works, okay, how we extract the features, especially the important features from the big data, okay, we'll just cover in the next slides. Then for implementing this deep learning technology or the deep learning models, and for development of the deep learning model, we need the Python programming. Actually, Python programming is gaining popularity nowadays because of deep learning came in the market. Okay, so lots of deep learning libraries, popular deep learning libraries have been developed using Python. I was just looking through the timetable of these training programs, and I saw that Dr. Somin Palsar has already covered the R software. So when in R software, we install the package, you download the package. So this package or libraries, actually in programming language, we use the term libraries or package. Okay, we'll just give intro to the Python language and the importance libraries of deep learning. And then the most important part of this training session, of this training lecture, is the demonstration with the live data set, MNIST data set, where we'll see that by writing a text actually the numbers, okay, the handwritten number, we'll write any handwritten number and it will be detected by the machine. Okay, so let's go one by one. So what is artificial intelligence and why it's not real intelligence? The term artificial intelligence, because we put intelligence on machine, and we know that machine can't understand beyond the 0 and 1, the switch off and switch on. And the main philosophy behind this artificial intelligence, the main philosophical questions behind this artificial intelligence, that's, can a machine think and behave like humans do? Can a machine think and behave like human do? जो machine है, that is that can't understand beyond 0 and 1, and we put intelligence artificially on the machine, that in such a way that it will act like human beings. That's why it is artificial intelligence, not the real intelligence. These questions were first raised by the father of artificial intelligence, John McCarthy. So the photograph was taken in Stanford University while he was demonstrating the chess program. And he defined that artificial intelligence is the science and engineering of making intelligent machines, especially the intelligent computer programs. And artificial intelligence is actually the combination of our amalgamations of various departments, especially the computer science, statistics, the neuroscience, psychology, etc. So he defined it is a science and engineering. We have to do programming. We have to do especially the statistical programming. Nowadays, we popularly use the term the smartphone. And where the smart word came, behind this smart, the intelligence came. And behind this intelligence, statistics came. Because in statistics, we learn by example. So machine learning, the main concept of machine learning is learning by example. Or where the term statistics came, the error involves. So by minimizing the error, by learning through examples, that's why this is the big umbrella, artificial intelligence. Okay. So as I told, please mute, sir, Professor. Okay. So as I told earlier, artificial intelligence is a very big umbrella term where which enables the machine to mimic human behavior, acts like a human being. And machine learning is a subset of the artificial intelligence, where we put some statistical methods, we develop some statistical methods to enable the machine to improve the experience or learning by experience. And deep learning is again the subset of the machine learning, where this learning experience are gaining actually more number of hidden inputs, hidden layer and pattern learn in the deep learning phase. So artificial intelligence is a very big umbrella term, and then machine learning, then deep learning. So I think lots of topic of deep learning will be covered in this lecture or has been covered already. So we'll not go to the details of the machine learning technique, we'll directly go to the deep learning techniques in this lecture. Okay. So this is just one slide of machine learning techniques. We know that machine learning techniques only divided into two parts, supervised learning techniques and unsupervised learning techniques. So what is supervised learning techniques? Supervised learning techniques where outputs are defined with respect to the inputs. Suppose we involve the weather data for predicting the pest population. Suppose we want to predict the we want to develop the model for the aphid attack in the mustard field, or whatever the crops and on which the insects or disease attacks. Actually, we know the insects and disease appearance depends on the weather parameters. So weather parameters involves the maximum temperature, minimum temperature, relative humidity. These are the independent variable on which the number of pest population or disease attack will depend. So this is the supervised learning technique. Actually, on the basis of this weather data, how much pest population came. Actually, NICRA project, I think all are aware, all ICRs people are aware with this project, NICRA, National Initiative of Crop Resilience Agriculture. So here, the input data set is the weather parameters, and the output data sets are the number of pest population attacks. So here is input data and output data. So this data set is called the supervised, and the model generated from this data set called the supervised learning techniques. And it's again divided into classification and regression. I'll not go to the details into the details of this machine learning techniques. And another is unsupervised learning technique, which mostly called the clustering techniques, where we didn't give the outputs actually, and through which some patterns came and clusters are defined. So in the next slides, we'll go through the details about the neural network. Here we can see that in case of supervised learning technique and in case of supervised learning technique and unsupervised learning techniques, both the techniques, the neural networks came. Okay, so neural networks plays a big role develop this deep learning model. So neural networks is the inner structure or the basic structure of the deep learning model. That's why the next slide will just introduce the artificial neural networks. Again, it is artificial neural networks. The name artificial neural networks came from here. Actually, this structure is inspired by the structure of the human brain, actually the neuron. Two dendrites you can see in the left window. In the left part of the window, that there is a simple structure of neurons, and through dendrites or dendrons, the signals came, and through axon, we can add something. So in that cases, in the structure of the artificial neural network inspired by the same neuron architecture, where this is nothing but your input data set. We can say it is a input layer, and this, the bias, the activation function, will not go to the details. What is bias? What is activation function? And this, we can say, this is the hidden layer. The input layer is the in case of weather parameter. These are the input data, and output data is nothing but the pest population. So, and by this way, machine learn. The statistical techniques involves to reduce the error, to minimize the error, or to optimize the error. Okay, the activation function involves. So this is the basic structure of the artificial neural network. Okay, so next, in case of simple machine learning techniques, it involves a human intervention to extract the feature, and then we train the machine. It involves the human intervention to extract the features. Suppose we want to classify an object, input like here is a car. Okay, so this is car or not car. Okay, this is the classification task. Okay, if we want to classify this, we have to extract manual feature extraction. Okay, we have to extract the features manually. So from this image, we'll see later how the features are extracted, how the image processing. Actually, the deep learning techniques is gaining momentum, and it's taken the technology. It's taken the inner technology inspiring from the image processing. So how this image processing inspired to develop these deep learning techniques, we'll see in the next slides. Okay, so from the input data, features are extracted, and this is a simple neural network technique. So that this is the input layer, this is the hidden layer, and this is the output layer. And ultimately, decision has been taken that this is car or not. But in case of deep learning, not needed any human intervention. Automatically features are extracted, automatically important features are extracted. Machine learn itself. Okay, machine learns itself. We can say the feature extraction task and the classification task, both tasks are done by the deep learning technique alone. And then we can take decision, it's a car or not. Okay, so next slide, this is the real world entity. We can say that in case of auto driving car, robot driving car, the special techniques, the encoder decoder segmentation network, special techniques, special deep learning techniques used in this auto driving car. Then you can see this image recognition or object recognition task. Actually, Sir Francis Collett, when in 2014, I think one feature, I think you are all aware with one feature of Facebook. That's suppose in your accounts, you have uploaded your photos and some friends tagged you. Then you can see on your face there's some square boxes came. That is actually advanced deep learning techniques, and it's called RCN, reason-based convolution neural networks. We'll not go into the details of these techniques, but this types of techniques just developed recently in this from, we can say, from 2010 or to 2020. These advanced technologies grown. Then we can detect this text. Okay, so we will do this demonstration, the 5041, the handwritten numbered recognition or handwritten text recognition in this example. In this lecture, we'll do this practical. Okay, then the handwritten text recognition, this is most important. Voice recognition, voice activated assistant, deep learning in healthcare, in all sectors. In all sectors, deep learning techniques having a bigger role. In medical science, particularly in the medical science, and in case of biometric, in maximum sectors, these deep learning techniques works. But in case of agriculture, also lots of technologies, lots of work have already been done in the agriculture field. And that's in this lecture we can identify the which types of jobs we can do by this types of methodology, this types of technique. Okay. And in case of agriculture, this deep learning techniques already applied in the crop monitoring field using the Internet of Things, IoT devices, and the drone technology. Actually, drone technologies is gaining momentum. Through drone technologies, we can take the input images, and from these images we can take decision. And these types of decision can be implemented to develop the IoT tools, Internet of Things tools. We can program in the microprocessor to develop automated tools. And this is the most common example in the left side of the disease classification. So there is one project under NAHEP component 2. That's this disease detection mobile app already available, already in the working condition now. So through this mobile app, you can take the images, and it can and the next step it can be detected that this is this disease. So it is actually a revolution in the agricultural field, and where farmers in the field itself can decide that this is the image, and on which basis, on the basis of its severity, how much fungicides or pesticides we have to spray on the fields. Okay, so these are the technologies. And in case of plant phenotyping, GWAS mapping, those who are aware of these techniques. I have also done my PhD work and MSc work in the plant phenotyping, and there is a robotics plant phenotyping facility in Nanaji Deshmukh Plant Phenomics Center in IRI in Plant Physiology Division. These types of imaging technology, actually computer vision. The term computer vision involve the two topics, that is machine learning techniques and artificial intelligence, and both in this computer vision having a bigger role to play in the agriculture. So all the plant physiological characteristics in a high throughput and in a non-destructive way, without destructing the plant parts, we can detect the chlorophyll content, the biomass of the plant, the nitrogen content, its height, and we can predict the yield. So these types of deep learning technologies. So I will also present my in one slide my PhD work. So these types of softwares I have developed in my PhD work. So having deep learning techniques having bigger role to play in the plant phenotyping and particularly in the agriculture field. Okay, so as I told earlier, in case of simple learning techniques, in case of artificial neural networks, what happens is just single hidden layer or 1 to 2 hidden layer. But in case of deep learning techniques, it involves both the things, the feature extraction as well as the classification. So maximum number of hidden layer involves here. Okay, so in the next phase, this is the inner technologies. I will just give the overview that how the features are extracted, how the important features are extracted through convolution neural networks. I will not go into the details of the statistical technique. I think overall structure will be understood by all the participants in a simplistic way. So the basic of the deep learning techniques involve the convolutional neural networks. Convolutional neural networks. Actually, what we see when we capture an image, we see an image, but how the computer see an image. An image is nothing but a two-dimensional array of picture elements or pixels. You can see here, there is nothing but a two-dimensional array of picture elements or pixels. Suppose we write cross here or 0 here. Okay, so this particular image is represented in the computer hardware in this form, two-dimensional array of picture elements or pixel. So now we'll go to the details of the convolutional neural networks. The basic of the deep learning techniques is the convolutional neural network, and where the first layer is the convolution layer, Second layer is the rectified linear unit, ReLU layer, popularly known as, then pooling layer and fully connected layer. We'll go one by one. Okay. This is very simple, not tough. So as I told earlier, this cross and this X and O symbols are how it is represented in the machine in the two-dimensional array of picture elements or pixel form. Suppose someone wrote X like this, okay? Using the pen. Someone wrote X like this, someone wrote X like this, okay, someone this, okay. So various types of structure, handwriting of one person is different from another person. Actually, handwriting is not same for all the person. That's why it's deeper. So how this different handwriting has been represented in the picture elements or pixel form? This is just represented here. Now, in the next slide, suppose here I've just put some numbers. Okay, so numbers यहाँ पे क्या है? So where this pixel, this X cover, we put the number. Where the X cover, suppose here is X, okay, and the digital number line is actually in pixels. The pixel values are represented in the form of digital number in the computer. Suppose we put this 1111 here and 111 here to cover the X. How this picture elements or pixel values represented in the computer. So everything is number. Okay. So whether it is pictures, whether it is text, agar number nahi aaye to we can't develop the statistical technique, statistical model. We have to deal with number. Okay. So we have to convert this image in a number, in a digital form. That is a completely imaging science. I'll not cover in this lecture. Okay. So how this digital number represented in simple camera, simple image you take using your mobile camera. While you will open this image through any image processing softwares like MATLAB, ImageJ, then you can see each picture values, pixel elements or digital number. So through this digital number, by using the digital number, we develop the model. So this digital numbers, actually the RGB image, the red, green, blue image, in simple camera, we use RGB image. Okay. So these values are related with for taking any decision, like in case of plan phenotyping, if on some leaf there is some pest attack or disease attack happen, and will capture the image. Okay, so the pixel values will change. So by taking this pixel value, we can develop model, we can develop statistical model, and then it can be used for taking decision in the further analysis. Okay, this is the number format. Now, how this convolution works? Okay, next actually, okay, here actually convolution work on a kernel basis. Okay, convolution layer has a number of filters for kernel to do the convolution operation. So how this convolution operation happen? I told earlier, the whole of this deep learning technologies, all of this techniques actually has been inspired from the image processing technology. In case of image processing, we commonly use one function, that is filtering. That is most popular in image processing, the filtering. Even in mobile, you can do, after taking an image. I'm writing with mouse, that's why I think it is visible to all of you, writing filtering. So in case of filtering, some 3x3 or 5x5 kernel, this called actually kernel. Okay, this called kernel. I have taken one image and I have applied this types of filter, 3x3 filter. This is nothing but a values. Okay, 3x3 filter on the image. If you want to do filtering on the image, okay, in Facebook, in case of any websites, where whenever you upload photos, you we commonly use the filtering techniques. These filtering techniques are most common. So what are the inner technologies in case of the filtering techniques? It's apply some 3x3 kernel or filters on the main image, on the root image, and then some features are came. Okay, then some features are come. So for the feature extraction from the image, from the text, from the audios, from the visuals, these types of features, these types of convolution filters or technologies used. So this essence has been taken from the basic image analysis techniques, that is known as filtering. Okay, so now how the features are extracted? How the features are extracted from an image, from a text, from an videos? Okay. So it's in the first step is line up the feature and the image patch. Then it's multiply each image pixel by corresponding pixel, then obtain the values added, then divided by the total number of features. So these are the steps. Okay. Now this, just see here. This is the most important phase of the deep learning, how the features are extracted, how the important features are extracted. So as I told earlier, this is nothing but a kernel filter having some values, and this is an image. Suppose this is an image of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 by 9 matrix. We can tell it's a 9 by 9 matrix. Okay, 9 by 9 having an image, having pixel size 9 by 9. Okay, so and this is the kernel. So if I put this kernel in convolution, how we extract the feature? If I put this kernel here, this kernel will put here in this image. So it will multiply. First step, it will multiply the whole process. So this is the kernel, and this is the whole image. And when we apply this filter on this side, so this one will be multiplied by this. These values will be multiplied by this, and this one it will multiply here 1, then -1 will be here. Okay, and by doing this, after doing this, it will do the addition task. It's a very simple task. No statistics involved here. Very simple operation, convolution, very simple image processing techniques, and it's having a bigger impact, bigger role for developing the deep learning model. Okay, so by adding this, after adding this, we have to divide it by the size of the kernel, that is 3 by 3. 3 by 3 is the kernel size, and 3 by 3 is 9. If we divide it, it's a 9, then it will be 1. So whole from this image, when this particular kernel will be put on the image, so this features will be extracted. So this is okay. In the next slide, you say this here, the kernels applied, and after this pixel values have been given. Okay, so by this way, if we apply this particular kernel here in the middle of this image, then the value after multiplication, these values will be replaced by this. Okay, this is not too much statistical techniques involved here. This is a simple mathematical technique, convolution. Okay, so by this way you can check, and this kernel will travel whole the image. To hold the image, this kernel will travel. Okay, so by this way, so this will be the values. Now we can tell that this is the 9 by 9 image, 9 by 9 pixel image. After convolution operation, this has been reduced to 7 by 7. 1, 2, 3, 4, 5, 6, 7. 7 by 7 image. Okay, so the image size has been reduced. But if someone want to tell in the deep learning, we want to capture the corner pixel, okay, then we have to add a number 0. It's called zero padding. Okay, zero padding in the image. If we want to capture the corner information, then we have to apply the zero padding on the image. Okay, so the moral of the story is here, convolution. In case of convolutions, how the features are extracted to the kernel or to the filter. So this is the technology. And when we'll cover the demonstration part, at that time will take as how the features have been extracted. Okay. So these are the several pictures, several kernels or filters. Suppose this is for extracting the height, this is width, this is yes. From one image we can extract the several features. From one image we can extract the several features, and after applying this several filters or kernel, these types of feature maps are generated. Okay, this is the convolution layer. After convolution layer, what done? That is the ReLU layer. And what is ReLU layer? In ReLU layer, what we do? In ReLU layer, having some values, we can see that there is some values in the negative form. Here some values in the negative form. Just a second. Here some values in the negative form. So the negative features or negative forms we have to remove. For removing the negative values, there is a simple mathematical techniques, and it's a simple mathematical techniques have resolved maximum problem of learning. Actually, in case of simple machine learning techniques, one major problem is that is the models overfitting, or the errors doesn't minimize epoch by epoch, iteration by iteration. Those are from computer science or statistics people, they can understand. And these types of features, the ReLU operation, the linear rectified linear unit, this activation, what done is a simple technique. It's just take the maximum values. Just take the maximum values. If some values are positive, then it will take, and if some values are negative, then it will be replaced by 0. We can see that this is the image. This is the image after convolution operation. After convolution operation or applying this convolution filters, this features maps have been generated. So from this feature map, we can see this is the negative values. Okay. So by applying this ReLU operating function, so what's ReLU done? अगर हमारे पास कुछ value positive है, then will not replace it, and if some values are negative, then it will replace by 0. So you can see this values is replaced by 0, then again this value is replaced by 0. Okay, so in this way the less important features are already subtracted. But in case of simple machine learning techniques, we have to, there will be all the features, whether it is important, not important, all the features are covered. Okay, but in case of the deep learning techniques, in the preliminary way, before going to the input layer, first input layer, we remove all the less important features. We only deals with the important features. While we'll do the demonstration part, you can clearly separate that's how the important features are extracted. Okay, next here, the most important layer is the pooling layer. Pooling layer is nothing but a simple here also simple mathematics involved. Okay, so we'll not go to the theory part. Here some 2 by 2 window will arise. Okay, just see the slide. 2 by 2 window will arise. Okay, from this 2 by 2 window, it will capture the maximum values. Here the maximum value is 1. From this 2 by 2 windows, it will capture the maximum values and it will be put here. Okay, so by this way, some more important features will be covered. So if we will take it is nothing but a 7 by 7 image. Okay, it is 1, 2, 3, 4, 5, 6, 7. The feature map of 7 by 7, and by pooling layer, the size has been reduced by almost half. It is 4 by 4. It is 4 by 4 size. Okay, by this way, the important features are extracted in the pooling layer. And next, we can see this is the root image, this is the main image, and from this image, by applying the convolution operation, the ReLU operation, and the pooling operation, these types of features are generated. Okay. So after generating this types of feature, it has been flattened. Actually, we need the input data. Ultimately, we need the input data. How the input data is generated? We have to flatten. This is suppose 1. Okay, this value. and these values. No statistical techniques are involved here. Okay, this is a simple mathematical technique and nothing, no more complex formulas here up to this. Okay, so by this, using this simple image processing technology, how the deep learning captures the important features. So by this way, we flattened, we develop a one-dimensional array. Okay, we actually develop the input layer. By this way, we develop this input layer. This 1, then 0.55, then 0.55, then 1. This will work as an input data in the fully connected layer. So in this way, X and 0 will be represented in the first layer, in the fully connected. Okay. After this, these values will be used for training, for decision making, and this is the final step of feature extraction. By this feature, by involving these techniques, we extract the most important feature, and these features will be used to train the machine learning model, or particularly the deep learning model, and to develop and ultimately the prediction or estimation model be developed. Okay, so before going to the inner details of the results, how it's work, so here some introduction, as I told earlier in the content slides, there's some introduction of the Python we'll learn. Python is the high-level interpreted, interactive, and object-oriented scripting language. Okay, so Python is gaining momentum nowadays is due to the deep learning techniques. Actually, it's developed during 1985 to 1990. Okay, but it's gaining momentum nowadays from the 6 to 7 years is due to the development of this Python libraries of deep learning. And Python is actually a portable language. Okay, why it's portable? Why? Because it's work on the different platform. We can use Windows, we can use Linux, we can use another various operating systems. Okay, and it is extendable. It is easy to learn, simple. Actually, most of the biologists use Python language. In case of Python, most of Python is very easy to understand. Comparatively to the C, Java, C++, Python is totally object-oriented language and easy to understand and very easy to implement these types of program. Okay. So these are the common Python libraries. Common Python libraries, those are involving to develop the deep learning model, especially this Keras library. Then the NumPy library. Well, another is TensorFlow. Okay, these are the mainly libraries or these types of NumPy, PyTorch. These are the libraries I will cover in the demonstration part. And to develop these types of programming or to implement the programming, the PyCharm is the editor. And after developing the model, the deep learning model, if we want to host it in the web, okay, if we want to host it in the web, or if we want to develop the web-based software, and this is the API, Flask, the web development one drop at a time, that says Flask API. Okay, so now we'll go to the demonstration part, the most important part. Then again, we'll come to the slides. Okay. Is it visible? Okay, thank you. So for doing these types of program, for developing these types of program, we need Python in the system, or most easiest way to develop the deep learning program. We can create our account in the Colab, in the Google Colab. Okay, actually for to run this deep learning technique, we need the GPU, the RAM of very much amount actually, very higher memories and GPUs needed. So the easiest way to run a simple deep learning model, we can create a Google Colab, and by default, if you want to run the deep learning model or to develop the deep learning model in your system, in your computer system, you can install the Python, this types of libraries. Okay, one by one. So here I will cover a simple, as I told earlier, that this is the number data set. Okay, this is the handwritten number 0 to 9. So one of the most popular data set, MNIST data set. It's called the MNIST database. Full form is modified National Institute of Standards and Technologies from USA. This data set has been contributed in the public domain, and this data set consists of the 60,000 images for the training the machine and 10,000 images for testing the machine. Okay, so here in this lecture, we will develop a deep learning model to detect these types of data. These are the images of the sizes 3, 4, 2, 1, 9. These are the nothing but a handwritten digit. So here we develop a deep learning technique. So I am going one by one. This is one of the library. This is one of the library in the Matplotlib. So after completion of this lecture, I will share the code. Okay, you can easily create a Google Colab accounts and run this program, and it will be run automatically. So you can visualize it personally. So this is the Matplotlib library. Actually, the purpose of the Matplotlib, if we want to develop some plot, okay, we want to plot some, like in case of R, you want to plot something, graphical plot. For implementing these types of plot, we need a Matplot library. Okay, so I have run this code. So okay, and you can see that's roaming. So this is available in the public domain, no cost required. It's absolutely freely available. But if you want to purchase more space or memories, then you have to pay. And otherwise, it is freely available for the simply application. So I have already, this has been already run, and you can see that there's a green sign that has been run, has been completed. Okay, so we have to import the libraries part. Those who are aware of the programming language like C, Java, C++, whatever the programming language, you know about the package or library. Before doing any programming, okay, we need to install, we need to import the libraries. These are the simple techniques for every programming language. Suppose while you are using R, then you have to import the libraries to implement the specific function. You have to import, you have to download and install the libraries, and then you have to import the libraries for developing the program. This is the simplest, this is the similar way in case of Python programming also for developing the deep learning model. So main platform, main libraries to develop the deep learning model is Keras, and TensorFlow is the platform. Okay, Keras and TensorFlow are the main libraries, we can say, or main platform for developing this types of deep learning model. And why it is TensorFlow? Tensor means the dimension. Where the dimension is more than 3, more than 2, I think it's called the tensor. That's why the name TensorFlow proposed. And as I told earlier, that MNIST database contains images, handwritten digits, and it consists of the 60,000 training images and 10,000 testing images. In the next step, we'll import the another libraries. Suppose NumPy. NumPy is an advanced libraries. It is used to develop the arrays. Then Matplotlib, I told in random libraries, actually the images we have to divide this data set into training and testing randomly. Okay, that's why this random library, and it follows the statistical technique. Then Keras libraries, we have to import, and by running this technology, we can directly click here. You can directly click here to run this. It has been run. You can say, okay, the data set has been loaded. After loading of the data set, we can check. Actually, it is 60,000 database, 60,000 images, and each of size 28 by 28 pixels. Each of size, I'm zooming this. Okay. Each of size 28 by 28. In PPT, in PowerPoint, we check this. We dealt with the images having size 9 by 9 or 7 by 7. Okay. Here, each of the images, each of the handwritten digit having size 20 by 20, and 60,000 images for training and 10,000 for testing the image. Okay. So here we load the data set and we divide the data set into training, into testing. We can directly click here to run. Then these are the matplotlib libraries. If we want to check the data set, if we have to check the data set ke andar kya hai, you can see that this is class 4. This is example. Class 4, class 2, then this is also class 2, class is nothing but here is 10 classes, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes. So these are the data sets, sample data. We just run this part of programming. This part of programming is just to check where the data is or what the data is. Okay. So in the next step, we'll check the how this image is represented in the machine. Okay, you can check. So can you suggest what is this? What is this number? This is 7. This is 7. You can predict that this is 7. Okay, these are the pixel values. By default, the other pixel values are zeros. And where the objects came, it's having some digital elements or pixel values. You can say this is the pixel value of 7. Okay. We can again run this because it's randomly, we will take any other value. This is again 7. Okay, it is randomly, it is taken 7. Okay, no issue. So how the image in the machine or internally in a machine, how it is represented or what are the values? I told while I will presenting the PPTs, that's the digital number. How this images has been represented using the digital numbers. So this is the form, and the next way we learned what is flattening. So if there is pooled feature map and this has been flattening in this way, we already cover in the slides. And here what we'll save the training data. Actually what happened? We have data set of 28, we have the pixel size of 28 by 28. If we'll multiply the 28 into 28, then it will be 784. So for each image, we have to develop this flatten window for running this. Here we develop actually two models: simple artificial neural network model and deep learning models also. So how these features are extracted, we'll see now. Okay. Now what happened? Now this part of the programming, we know that there is a 10 classes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes. That's why you have to write the digit 10 here. And then for training and testing, we have to classify this. Okay. And after that, these types of layer, this type of simple fully connected networks, or the simple NN, we can say these types of network will be developed. Okay. So here we'll run the model sequential. This is the code, and here is the hidden layer. As I told, it consists of the hidden input layer. So this is the hidden layer. This is the input layer. First layer is the input layer of the 10 nodes. Then this is the hidden layer, 512 nodes, 512 nodes, whatever. You have to put some hidden nodes that's having the numbers 2 to the power, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power something digits you have to put in the real number. That is the norms. Okay. In the first hidden layer, you have to run, and after running this, don't get confused with this coding part. This is actually I will supply you, but here in this training program, I think it's just essence of how features extracted and in which way, in what way we can implement in our own field, having expertise according to your expertise in which field you can apply. Just you have to take favor from this lecture. Okay, so and this another techniques dropout. I will not cover the details of this. Okay, I'll directly go to the result. Okay, so here in the first thing, this is nothing but a simple artificial neural network. You can see this. These are the number of parameters. मैंने बोला था कि machine learning techniques में we have to ये totally features ले लेते हैं and then understanding करते हैं. So number of parameters are more to learn. But in case of while compile the convolution neural network, then we can check that this is the number of parameters, number of features are extracted. Now here we build a convolution neural network. This is the most important part of today's lecture. Okay, here by this way, this is the deep convolution network. By this way, we'll load the libraries, then the number of classes. These are the coding section I already told. Okay, I already covered in the first. Then for implementing this model, the number of convolution actually through this layer. So how much convolution filters? There's 32 convolution filter. Then size of each filter, that is 3 by 3. The activation function ReLU. By this way we can develop the deep learning model. By this way we can develop this deep learning model. You can check this number of parameters is very less for taking the decision. Okay, this is the main flavor of convolution neural network. So our main focus is how this machine learning, the simple machine learning technique differs from the deep learning technique by extracting only the important features or by concentrating only the important features. Okay, so this is the mainly coding part. Then the another thing is we have to apply some loss function. Okay, and why it is categorical cross entropy, I will not go into the details of the loss function, the optimizer, the method. It is totally statistical formulas oriented. So how the number of categories and loss functions and the optimizers involved to develop. You can check this. I have just clicked here and this iteration done. Iteration is going on. Actually, machine is training now. Okay. So training हो रहा है अभी. And I just put it for the two iteration. Two iteration का मतलब क्या है कि ये just जो पूरा model से the whole models will run at 2 times. Okay, so, I told already that artificial intelligence, the main essence of artificial intelligence is to is nothing but the learn by experience. Okay, ये जितना learning करेगा, numbers of epochs, although lots of factors involved for controlling the number of epochs or how much epochs will be decided, and that involves some statistical mechanism. Here you can see the accuracies acquires per iteration. This is actually the classification problem. I told this the digit, suppose 1 written by hand, and then machine will understand that this is particularly 1. Okay, now the most interesting part will test that this particular digit will be identified rightly or wrongly. Will test now. Okay, so the training part is going on. You can check epoch by epoch. The losses are computed. accuracies are computed. In the first epoch, we can say you can check just 89% accuracy. Okay, in the second epoch, 93%, 96% accuracy. In this way, it's gone. So it will take some time, 2 minutes more to run. And here the most important part is batch size. Okay, what is batch size? Batch size at a time. Batch size is nothing but at a time, how much image will go at a time, how much images will go. That is the batch size. And epoch is nothing but a iteration. They now training completed and model has been saved. Training has been done. Okay, you can check that this is by completion of the second iteration, accuracy is training accuracy. That is 96%, validation accuracy is 98%. Okay, now we'll evaluate the train model, the testing accuracy and the accuracy. So we can directly go to this part. This is the losses, the testing accuracy. Testing accuracy came. This is testing accuracy, validation accuracy 98.2% already here. So no need to run again here. Then we can test. We can predict the test. Okay. It's maybe lots of questions raised, but I'll go one by one while in the question answering session. And here is the most important part. MNIST datasets and classify. You can check here. You can check here. This is the most important part of this training session. This handwritten text. This is the testing images. I told earlier that MNIST dataset has been divided into two parts for training and testing. Okay, these are the test images. Randomly test images are chosen, and how rightly it's predict that this is the disease. It has been predicted as 9, and true is 9. True is 9, prediction is all right. And what is score? Score is 0.997. And what is score? Score is nothing but a probability value. Where the term, this types of machine learning statistics came, the term probability came. So we'll tell that this particular digit is 9 with this probability, 0.997. Here is 0. This particular digit is predicted as 0. 2 is 0. Prediction is 0 with probability 1. 100%. We're confident. It is 3. I'm predicted as 3. You can check. You can see here how machine has been learned. So this is the simplest application. One of the simplest applications that how the features are important features are extracted, and this is the advanced the technologies of deep learning from the traditional machine learning techniques. So automatically features are extracted, and by learning from the important features, okay, we can develop the most robust deep learning model. Okay, this is the mostly. I will share the coding part after this text documents. You can create your account in the Google Colab and you can run this. As usual, the code will run. Okay, you can test it. Now, my query is by from this lecture, you can think this how you can apply this types of technology, this deep learning technology in your fields. Okay, so now I'm again going to this. Just a second. Okay, from here we going to the part, the demonstration part. Now the slide is visible to all of you. I think visible. Okay, so now this is another case study in my PhD work. Just 2 to 3 slides to complete. In my PhD work, what I have done, I have developed a deep learning model for automatically identification and counting of spikes in the wheat plant. Actually, for predicting the yields, okay, or estimating the yields from the plant phenotyping system, actually, if we through imaging, will automatically detect the spikes, and from spikes we can predict the yield. So this is the robotics facility I told. The Nanaji Deshmukh Plant Phenomics Center, the Indian Agricultural Research Institute (IRI) under Plant Physiology Department. This is the robotics facility. By using this facility, I have taken the images, especially the visual images, RGB images of wheat plant. Okay, and from by the after taking these images, I have developed the deep learning model. So my PhD work, mainly my PhD work, is to develop a deep learning model to automatically segment the spikes from here and down. Actually, in case of plant phenotyping domain, for developing a high throughput plant phenotyping facility, high throughput and rapid plant phenotyping facilities, we need a faster data. So this technology will be utilized for extracting these types of features and faster data and to predict the yield. And this is the inner of the spikes. And I will not go to the details of this model. And after developing this is also the basic convolution ReLU. You can see that these are the convolution operation. Okay, max pooling operation. Those the topic, the simple mathematical techniques I covered. This is nothing but an advanced technique. And this technology, this architecture were inspired from UNET. UNET is popularly used for detecting the breast cancer. Okay, developed by Rosenberg et al. In his paper in Nature Methods in 2015. So in my PhD work has been inspired from this work, not actually this work, but has been inspired. I have modified the network, and happy to share my against this web spike segment software. After developing this deep learning model, this model spike segment model, this is already available. Copyright has been approved. Okay, by uploading the image, one can plant physiology, because this is very useful software for the plant physiologist. Automatically spikes will be detected, spikes count, and on the basis of spikes count and area, we can directly predict the yield. We can directly estimate the yield of the plant. I'm happy to share this two publications, one from Plant Methods Journal and another from IEEE Access. Another now in the pending from my PhD work. Okay, and if any questions, and then thanks dear participants for patiently listening me. And if you have any question, please raise me. Thank you.
Thank you. Thank you, Dr. Tanuj.
Thanks, ma'am.
Very nice presentation. You have made the deep, complex things very simple in your lecture. I am not sure about how participants have perceived it, maybe because it is different from what they are used to listening. So, but I'm sure they must have appreciated some of their myths might have been resolved. Like common myth about deep learning is it is some kind of button, like some kind of machine, like which if you give, then it will give you straightforward the answer kind of thing. So this also tells how much hard work is required for using this deep learning for any specific problem. So now Tanuj has not like made you understand what exactly deep learning is. He also demonstrated. So if you say picture is worth 1,000 words, then I would say a demonstration is worth 10,000 words. So he has demonstrated how a simple program is there to do a very simple task of recognizing the digits, handwritten digits, and how accurately the program was able to recognize those handwritten digits using machine learning, using deep learning. So now, not only that, he also gave you one application of it, real application, which he has developed. That is to count the number of spikes in the wheat plant. Of course, that was in experimental conditions. but not far are the days when this can be applied to the field also to detect the yield, actual yield from the plant. So more and more research will come for that. So now he's open for questions. If you have any questions, please, like you can ask him. Tanuj, I would just like to say some persons, they are attending this meeting in attendee mode and some are in panelist mode. So some cannot ask question directly. They will ask either in QA or in chat box. So you can go through chat box or I can read it for you.
Okay.
Maybe let us see one by one. One question is there scope for social science research in AI and machine learning? Okay, let me answer this question to you. Because I have been associated with this social science research from such a long time, so I understand this. Basically, AI and machine learning, as you saw Dr. K.N. Singh's presentation also, he has used it for yield prediction. And he told you why he termed his method as machine learning, because that was data driven. So that, of course, I think no agriculture scientist will deny that that is very important to predict it in advance, so that in future it is going to replace those crop cutting experiments. Another thing is like if by images of fields you can know from like what kind of losses the farmers have occurred. Now when applying for insurance claims and other things, farmers, they are struggling, they do not get their claim, and sometimes the insurance agencies and all, they will take it as a false claim, and sometimes farmers actually might be doing that. So when you have images of the fields at different points of time, you know what is the exact loss, you can predict the loss of the farmer. So this is also one application. And as an advanced, if I go maybe 50 years hence after, then nowadays you go to the field to collect the data. How much is your production? How much is this and that? Maybe on drones, like now Prime Minister is putting stress on drone-based farming. So drones are taking images of each farmer in the country, and then you need not go to the field to collect the data. So some deep learning algorithms, they are generating the numbers for you. So that is something like some vision about of this. So like that, you being the social scientist, like my job was here to introduce you to this upcoming technology. So much myths. I know even in my own institute, people do not have knowledge of what exactly it is. They think of it as some kind of God who can solve every problem. And this is my answer to one of the breakout assignment I gave, whether it is going to generate or aggravate the problem of employment. So we will require people for developing such kind of models, isn't it? So only thing is, it is not going to create such technologies, AI technologies, what people are fearing. They are not going to, aggravate the situation of employment. But only thing is, people will have to develop more skills to gain more employment. So, and which is true for every technology which we have. So you have to gain skills. So this is one thing. In fact, I have told Tanuj that in advance itself, that people are here, extensions, economists, statisticians, who may not have iota of idea regarding AI, machine learning and deep learning. He has to give that flavor practically. So it was really a tough task. And I would say like Tanuj has successfully done that task.
Thank you, ma'am.
This is not so easy to represent such a complex topic in such a easier way. So this is really, I think, appreciable. Lots of applaud to you, Tanuj, for
Thank you, ma'am.
doing that. Thanks a lot. Now let us see the questions and the comments. I will read it for you. Okay, then it says, somebody is saying, I could not perceive all the information because it was computer-based programming, but new idea I gained. Yes, you are right. Because one cannot learn new idea programming in a day. But if you have to get your task done, then you should also know what the technology is about. To get the exact words and numbers from the websites or from the files, what kinds of techniques can be used? Okay. So Tanuj, you would like to answer or should I answer?
Yes, ma'am.
There is one question: to extract words and
numbers from the
we are
website.
talking about web scraping.
Okay, web scraping.
Yeah.
Yes, ma'am. We can do this by applying this technology. Actually, it's having lots of way we can do such way that's a web scraping, and you can also use these types of techniques by using snaps from the image. If you convert in the image, then it will be easy task for the deep learning models or to develop the convolution neural networks, and through which we can predict the text and predict the number. We can to extract the words, and there is not only the deep learning way. The another technique is web scraping. We can use web scraping for solving this problem. Thank you, ma'am.
Yeah. So as he has rightly told, basically that is not that actually doesn't come into the category of machine learning or AI. It is a kind of programming. So that level of programming is possible. So which comes under the technical name given is web scraping. So by doing that, one can get the things. Again, codes and algos are developed for this, and some softwares are also coming for this. So people are thanking you. I think that's all about this. Lots of appreciations are there. Then I find in Q&A. Can we read the filled-in interview schedules and get the data out of it? So what he means is, like, if you have the schedules field and using this image processing, can we get the data out of that?
Schedule field, what is one?
The questionnaires. Like
okay.
Questionnaires, questions, surveys basically are there where we ask questions from the farmers and they are filled by the field investigators.
Okay.
As a researcher, they normally do entry of that.
Okay.
And then they analyze it. So he says, can the machine read it for us and
from
data?
Okay, that means it's a
right now.
Through which data came? Through text or voice, through message? So by not entering any data, and we can predict.
No. He is not saying this. He is saying, let me answer this question.
Yeah.
He is saying that we get the schedule from the fields, from the farmers. They are field schedule. He is not saying unfilled. So as
field schedule, okay.
Yes.
Which type of schedule, ma'am? Which type of schedule? Actually, I'm not getting. Which type of schedule? Field schedule.
No, farmers in social science, basically they have surveys.
Okay.
Designed for the farmers to get the data from the farming field.
Okay.
Those survey schedules, you see the application he has shown. like you are detecting the numbers, and that detection was 100% almost correct, even though sometimes machine has told that this particular recognition is 99.7% correct. But from our own knowledge, we saw the example he has shown, it was 100% correct. Similarly, for every alphabet, every number, every character possible, one requires some kind of algorithm for recognizing that. At present, naturally, some commercial people have to come for such things, but you are already aware of these OCRs are there, which
OCR, yes.
which are used for
Optical character recognition.
evaluating the exams. And sometimes like in machine learning, you have seen in YouTubes and all, captions are coming on its own. It is recognizing the language, basically voice, and translating it. So same way, the days are not very far away for having that. But at present, I have not heard of any software which can make your task so easier. But of course,
actually, this is, I think, a job of handwritten text recognition, madam.
Yes.
Is it okay? Handwritten text. Okay.
Yes, that's what I'm saying. That it is that only. But
okay.
Software wise, I have not heard of anybody having implemented this at that level.
Okay.
Of course, it comes under that category.
Comes under this category, handwritten text recognition. Actually, before 5 months, some legal image pages actually came to some employee of the court actually connect me, and he told that these are the pages. Can we detect this? I was working on it at that time. So some libraries are there for detecting, for auto detecting. 2 to 3 works has been done, madam, for handwritten text recognition. But I'm particularly not in touch of it. But this is possible, handwritten text recognition. But
this is
having
possible.
having lots of error because in handwritten is actually कब कोई वर्ड कैसे लिखेगा उसका ऊपर बहुत डिपेंड करेगा. मगर ये पॉसिबल है, ये हो रहा है. It's possible.
It is under the category, same category what he has. So it is possible, but at commercial level, to ease your task, software we don't have. Any such software we don't have. Research is going on, as he has rightly put, legal documents. I mean, they're being recognized. So using this deep learning, that work is being done by somebody. So it is the stage of this is still under development. Technology is under lots of development. So applications are coming. So that's the idea. So I don't think there are much questions, because naturally it was out of, I mean, their direct scope. But now, at least when they are imagining some application related to deep learning, I think they will be more intelligent, and they will be rightly able to put their perspective related to this technology. So thank you, Tanush, once again.
Thank you, ma'am.
On behalf of my participants, as well as on behalf of organizers, like you could devote time even on your holiday, because you were not having time on other days. So that's great. And
first of all, thank you for giving me the opportunity, madam.
Yeah, thank you.
And in my MSc and PhD throughout period, you guided me a lot. And thank you. Thanks to the dear participants. Also, thanks to the organizing team again. And
thank you. Thank you. We look forward for